Alright, so we saw set operations in the last section, and we're going to look at some more set operations, but what we're going to do is we're going to complicate things. We're going to take more than one set operation and kind of see how that works, how that looks in terms of Venn diagrams, and how that plays in what kinds of things are equal, and so on and so forth. So, like I said, when I say complex, I don't mean anything new. I just mean here's what we're going to do with multiple operations. And I will emphasize that order is important. Just like when we deal with multiple operations, anytime you're in a situation in mathematics where you have to deal with multiple operations. So let's just take multiple arithmetic operations. Something like 5 plus 3 times 4. Right? Order is important. Knowing which thing to do first and which thing to do next is important. All right? Obviously, when we do 5 plus 3 times 4, you have to multiply before you add. Same thing with set operations. There are certain set operations that take precedent, and we'll kind of see that as we get through some of these ideas. So here's the deal. Let's pretend we have a universe which is the numbers 1 through 10, counting numbers 1 through 10. A is going to be 1, 2, 3, 4. B is going to be 2, 4, 8. All right? Now, just like regular arithmetic, parentheses take precedent over everything else. So what that means is you need to simplify what's in parentheses before you do anything outside of it. Okay? And here we have a union and a complement. And we have an intersection and a complement. So what the parentheses tell us to do is to find the union first and then take the complement of the whole thing. That's in this first one. So take the union and then the complement of the whole thing. In the second one, it's intersection, and then the complement of that set. All right. Now, here's a couple of tricks. When you're doing these set operations, don't try to do them in one fell swoop. It's gonna crush you if you try to do these in one fell swoop. So what I mean by that is don't try to get the answer right away. Okay? Just like when you have a really ugly looking arithmetic problem where you have addition and multiplication and exponents and parentheses, you don't want to obviously just try to get an answer right away. You want to do your operations and be careful about it. So what I'm going to do, and this is how I think each one of you should do this, is find the union and write it down. So A union B is 1, 2, 3, 4, and 8. That doesn't look very good, but so I found the union, and now I'm going to take the complement of that. Notice that I didn't try that all at once. So now I can take the complement 1, 2, 3, 4, and 8. Complement, well, there's no 5 in there, there's no 6 in there, there's no 7 in there, there's an 8, there's no 9 in there, and there's no 10 in there. So the complement of A union B is 5, 6, 7, 9, 10. All right. Now I want you to push pause and try to do the same thing for the intersection. All right, so hopefully you tried that. What we're going to do is we're going to take the intersection. Intersection of A and B is 2 and 4. And I want to take the complement of that. So I want 1, 3, 5, 6, 7, 8, 9, and 10. Alright, so let me make sure that that has everything except for 2 and 4 in it. Yeah, it looks right. So 1, 3, 5, 6, 7, 8, 9, 10. That would be the complement of the intersection. Now, when things are denoted this way, with complements and unions without parentheses, then it should be fairly obvious that sort of complement, you have to do the A complement first before you start trying to intersect it with the B complement. So you do the two complements and then you intersect them. Okay? So again, that's what we want to do. We want to write those kinds of things down. So take the complement of A, that is 5, 6, 7, 8, 9, and 10. And I want to intersect that with the complement of B. So complement of B is 1, 3, 5, 6, 7, 9, 10. Alright, so I'm looking for the common things in this. We have a 5, a 6, a 7, a 9, and a 10. So 5, 6, 7, 9, 10. 5, 6, 7, 9, 9, and 10. And so once we have this, pretty clear that that's the answer. And it's pretty clear that that is going to be really, really hard to do. If you try to jump from this A complement, intersect B complement, to the very final answer, it's going to be a hard run of things. So take this in step. Do each one of these steps separately. Take the complement, intersect, complement. And again, if you do everything right, you'll get to the final, what you wanted. So I want you to try that for the next one. And push pause on the video, try this, and then come back in about 5 seconds. Alright, so A complement, I'm going to write it down again just because I want to be thorough about this. 5, 6, 7, 8, 9, 10. Union 1, 3, 5, 6, 7, 9, 10. All right. So if I union those things, I am going to get, I'll have a 1, a 3, and a 5. 1, 3, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. All right. So that would be my answer. Now I hope you notice something about these two sets and something about the two sets on the previous slide. In fact, they were the exact same sets. Okay, so we're going to look at some equivalences in just a second. So what we saw in our example was that if I had A union B, and if I unioned first and then took the complement, that would be like taking the complement of each and intersecting them. All right? And we also had a very similar result on intersections. So let's draw this and kind of what's going on with in terms of Venn diagrams. And we'll see that Actually, that doesn't happen just in our case, but that would happen in every case where we have an A and a B with certain properties. So in fact, anytime we have an A and a B, that's going to hold. So let me do the idea here. So here's what we're going to do. We're going to draw a Venn diagram. Okay? We're going to assume they have some overlap. Now I'm going to describe this two different ways. And show you that we get the same either way. So first way, we're going to look at this. A union B. Now let me just put that A union B in blue. So if A union B, that's what we're looking at. So I want to take the complement of that. All right. So if I took the complement of that, so first off, that's A union B. The complement of that is going to be everything outside of the blue region. All right. So that's what's happening. Now, let's look at it another way. Okay? Let's take the A complement. Now, A complement is everything outside of A. So let's draw that A complement. I'll draw that in this yellow color. Everything outside of A is A complement. Now everything outside of B is B complement. So I'll draw that in different color. And I'll draw the stripes going the other way. So outside of B. Well, we could have that outside of B. So anything outside of B is B complement. Now, let's look at this carefully. So I have A complement in the yellow, B complement in the pink, and I want to intersect those two things. Now the intersection is where they overlap. So it's basically everywhere we have pink pink and yellow together. So we have pink and yellow together out here. That's pretty clear to see. In A, we do not have pink and yellow. We have pink, but not yellow. Over here, it's the opposite. In B, we have yellow, but not pink. So we see that where they overlap is just outside of the two circles. Right? So what's inside those two circles, in other words, in here, is not in this set. So we can clearly see that Venn diagrams show us that we get the same region in either case. And we can see a similar thing with the intersection. If we take the intersection, A intersect B, and complement that, we saw last time that we had our sets gave us this. So let's look at these via Venn diagrams. All right, we're going to go an A and a B, A, B. Over here, we'll do an A and a B. A, B. So first of all, A intersect B, we know that's in here. I take the complement of that, so anything in here is in the intersection. Complement is everything outside the intersection. So complement is anything outside that intersection. So that includes everything outside. I'll write it this way now. All right. Over on the other side, okay, so everything outside of A is A prime. So since we're going to do a union with the B prime, or the complement of B, everything outside of B is our complement of B. So I can, since I'm doing a union, I can shade in anything that is outside of A. Anything that's outside of A. Along with anything that is outside of B. So anything that's outside of B. And once again, see that I get the same area. Okay? It's basically, again, everything except for the intersection. So in both cases, you see that we do get the shade area, the same shaded area in the Venn diagrams. And again, this is not a funny way that I'm drawing it. It turns out, in general, no matter what A's and B's you've picked, if you take A union B and then complement the whole thing, that's like taking A complement and intersecting B complement. And if we have A intersect B, complement the whole thing, well, that's like taking A complement union B complement. So notice what's happening here is this complement is kind of, if you, it's not a proper way to say it, but if you distributed it into the A and the B, then you have to flip your intersection to a union or your union to an intersection. Okay, I'm being a little bit loose with the term distribute, because this is not necessarily a really distributive property. You can't distribute the property of complement, but that's kind of what's one way to see it. All right, so here's what I want you to do. We're not going to look at a general rule from this, but I want you to take the following three sets, A, B, and C, and the universe is going to be, again, the numbers 1 through 10. And I want you to find A union B intersect A union C and see what you get. So push pause on the video and do it, and then come back and see if you got the right answer. All right, so again, do not try to do this all in once. All right, we have a lot of operations going on, so take your time when you do this. So first off, A union B. A union B. So we have 1, 2, 3, 4, and 8. All right, intersect A union C. A union C is 1, 2, 3. 2, 3. Union C, 4, 6, 9. All right. So I'm trying to intersect those two sets, so I have to see what they have in common. So they have in common the 1, they have in common the 2, the 3, and the 4. And the 8's not common to both, 6 is not, 9 is not common to both. So this whole thing should be 1, 2, 3, and 4 as the final answer that you get. And this is what you get when you do that. Now again, I can't emphasize this enough. Do not try to find that on your own. Don't try to find that by just jumping to the end conclusion. All right? Take your time, do one step at a time, and do it correctly. All right, so now I want you to find a different one. Let's do A intersect B union A intersect C. All right, and see what you get on that one. Again, push pause on the video and then come back to see if you got it right. All right, so if I do A intersect B, that's a 2 and a 4. And I'm going to union that with A intersect C. All right, A intersect goes 1 and 3. So in this case, I get again 1, 2, 3, and 4. All right, so 1, 2, 3, 4 is the answer again. Now I know what you're thinking. You may think that means that those two things are the same. However, they are very much different, okay? One of them was a union B intersect. Well drawn. Intersect A union C. And the other one was an A intersect B union A intersect C. Now it happened that our A's, B's, and C's led to the fact that these were equal in that case, but I want to say in general that is not true. Okay? It is very much not true, in fact. So let me just draw a couple of Venn diagrams to show you that that is not true. All right, in this case we have 3 sets to deal with, so I'll draw 3 circles. A, B, and C. A, B, C. A, B, and C. B, C. All right? So, a couple things. Let's start on the left idea here. If I say A union B, all right, that's everything in here and everything in here. In fact, let me just take a marker. A union B is, I'm going to draw around here, that whole thing. Okay. A union C, well, A union C is going to be this idea. Okay. I'm trying not to draw too many fill-ins because it's a little bit cumbersome. If I need to, then we will. But in fact, yeah, let's do that. Let's fill it in right now. I won't draw too much stuff. So A union C is everything in there. A union B was everything in, I'm trying to think of where to start this, here. Okay? So we want to see where those things overlap. And if you don't see it in this picture, maybe I'll draw the next picture, draw a sequence of pictures. Where those things overlap, well, everywhere in A they overlap. So, everywhere in A they overlap. Color that in. And this little space here, they also overlap. Okay, so that little space we can color in too. All right. So this is A union B intersected with A union C. Now, on the right-hand side, if I take A intersect B, let's find a color. A intersect B is here. All right. A intersect C, well, that A intersect C is here. So if I were to draw, again, another Venn diagram and said, well, the union of those two things, you should be able to see it right here. But if you can't, let me draw another Venn diagram. Then what you see is this shaded area with this shaded area thrown together. All right. Now that is very different from what we had over on the other side. So in this case, it just turned out that in our case before, with the specific A's and B's and C's that we chose, everything was in one of these that was in one of these. All right. So, but clearly in general, we're not the same. So in general, these things are not equal most of the time. However, we just happen to choose our A, B, and C so that they were equal. Okay. Now, what I want you to do is, first off, I want you to find the following set, the A union B intersected with C complement. And then I want you to draw a Venn diagram where we have an A, B, and a C, and you shade in that region. So push pause on the video and try that out, and then come back. All right, so like always, make sure that you take this one step at a time. A union B is, in this case, 1, 2, 3, 4, and 8. Intersect C complement, that is 2, 4, 5, 7, 8, 10. All right. So if you intersect these, now intersection means what's in common. So we have a 2, a 4, and an 8 that are in common. So 2, 4, and 8 are all in common, right? 2, 4, and 8. And so that is the intersection for this the intersection of the union of A and B and the complement of C prime. Now, if we were to draw a Venn diagram, remember what I did, we unioned A and B, and we intersected that with the complement of C. So let me we'll draw a couple of diagrams. And just like, by the way, when you're doing this with sets, don't be afraid to draw more than one Venn diagram to show you sort of these overlapping, slash marks can be a little bit hard to understand in one. So make sure that, you give yourself the opportunity to succeed and take your time. Make sure you have more than one drawing and so on and so forth. All right, so A and B and C. We're going to do this A, B, C. Okay. A union B. Let's color some of these in. A union B. C complement. Well, C complement is anything outside of C. All right. Intersect those. A, B, C. So the intersection of those is going to be, well, where they overlap. We can see that they overlap here, here, here. They do not overlap in this space, and they do not overlap in this space. So where these things overlap is in the area that I've shaded in red. Now I'm leaving off the symbols A, B, and C, but those are fairly straightforward. Okay? So that's what's happening in the Venn diagram. So if I ask you to shade the region, or shade this, draw a Venn diagram and shade this region, then you would give me this as your final answer. All right? Now I want you to do the same thing with A union B intersect C. All right? So push pause on the video, see if you can do that. Again, we're going to do that both in this case, so give me a specific numeric answer, and then also draw the Venn diagram. Push pause and do it. All right, so let me take a look. A is 1, 2, 3, 4. We're going to union that with whatever we get in parentheses, B intersect C. So B intersect C is, now don't say nothing. It's not nothing. It's the empty set, right? The set of no elements. So there's no elements in the intersection. Okay. 2 is not in C. 4 is not in C. 8 is not in C. The intersection doesn't have any elements. So when we do a union, well, I union 1, 2, 3, 4, put that together with the empty set, I get 1, 2, 3, 4. And that's my final answer. Don't need to go on any more than that. So now let's draw the Venn diagram. A, union B intersect C. B intersect C has parentheses around it. So again, I'm going to draw a couple of these. So we have A, B, and C. So I take B intersect C. We're going to start out with that. B intersect C is this area. I'm going to take that and union it with A. All right. So A is this area. And if I'm taking the union, then I'm putting both of them together. So my final shaded region, I'll shade that in red. Since I'm putting these together, I can do it on one, is anything in red. That would be my final shaded region. All right, so not too bad. In fact, interestingly enough, we saw that earlier. We saw that same shaded region. And if you remember, that was the same shaded region we had for A union B intersect A union C. And in fact, these two things are equal in general because they have the same shaded region. If I take A union B intersect A union C, you get the same thing as A union B intersect C. So those two are in fact the same regions, and in general they are for no matter what A's and B's and C's we choose. Now we saw that, again, Venn diagrams can help us sort of decide whether things are equivalent or not. We saw a couple of equivalencies earlier. We just saw the fact that, A union B intersect C is the same thing in general as A union B intersect A union C. By the way, this is kind of like a distributive property where the union distributes. So this union, we have A, it's almost like times B plus C almost. Not quite exactly, but it's like A and B together, union B, A and C together. And we get the same sort of result if we did it the other way. If we'd have taken intersect in this regards, we could have done the A intersect B, union A intersect C. All right. And these are two general rules. You don't have to memorize these, but it is nice to understand that many things can be rewritten based on when we're doing more complicated set operations, when we have more than one. A lot of things can be rewritten in different ways. And even the set difference can be rewritten in a way with complex set operations. Let me talk about what a set difference is and think about that in terms of a Venn diagram. We just have an A and a B here, so our Venn diagrams are going to be a little bit simpler in this case. But we have an A, we have a B. If I say A minus B, well, all I'm saying is I take all the elements in A and I throw out the elements in B. So we're looking at that region there, the shaded region. Well, we could have said that, in fact, that's everything in A that's not in B. So if you wanted to write that as in terms of complements and unions and intersections, what you could have done is you could have said that is A intersect B complement. All right? Now think about that. B complement is anything on the outside of B. So what we're saying is anything that's outside of B, but that's actually an A, is in the set difference. So you could have written a set difference as an intersection and a complement of something. So A minus B is A intersect B complement. All right. So there's lots of these little nifty things that sort of immediately pop out at you once you've played around with enough Venn diagrams. So that's the idea. Now on a test, on a quiz or something like that, what I would do is I'd have you shade Venn diagrams and, given different A's and B's and things like that, I would have you, find some of these complex operations.